It's a crazy fisheye too, but it works out really well. All right. Okay, so ladies and gentlemen, we've done mole-mole conversions in stoichiometry, and we talked about limiting and excess reactants. We did that simulation yesterday. We're gonna have time to finish up the simulation today, and then work on a mole-mole limiting reactant exercise. But before we do, we need to do mass-mass stoichiometry. This is the bulk of stoichiometry. This is what's most useful to us. When we have grams of A and we want grams of B, this is the most useful part of stoich. Now, do we have a conversion between grams of A and grams of B?
No.
No, we don't. Good. So what we do have is a mole ratio, which allows us to convert, but we don't have a direct conversion between grams. So we have our diagram where we're at grams of A, which is what we're starting with, and grams of B is where we want to go. This is our ultimate goal. Okay, guys? Good. You need a calculator and a periodic table for this. So we cannot convert right from grams of A to grams of B, but we can convert from moles of A to moles of B using the mole ratio. And remember, where does the mole ratio come from?
Molar mass.
The gram to mole and mole to gram is molar mass. Where does the mole ratio come from? The mole to mole ratio. The mole ratio is moles of A to moles of B. Where do we find that conversion from moles of one thing to moles of another thing? Yeah, when we balance it, exactly. So when we've balanced the chemical reaction, those coefficients in front of the chemicals, that's going to be our mole ratio. So what we're going to be doing in about 30 seconds is we're going to be taking grams of A. We're going to convert our grams of A to moles of A. That allows us to use the mole ratio to convert from moles of A to moles of B. Once we have moles of B, then we can convert that moles of B to grams of B. Okay? And that's our goal, to get from grams of A to grams of B. We can't do it in one step, but we can turn our grams of A into moles of A, use our mole ratio to turn from moles of A to moles of B, and then use our molar mass once again to go from moles of B to grams of B. Okay. Any questions before we get right into it? Okay. Here we go. So, here's our question. How many grams of oxygen, O2, with excess hydrogen are required to produce 16 grams of water? So, we're going to make our T-chart. What's going to go in our first box of our T-chart?
16 grams of water.
16 grams of water. Once again, how many things go in each box?
3.
How many things?
3.
3 things go in each box. We have our number, we have our unit, and we have our label or our chemical. 16 grams of H2O is what the exercise gives us. Yay. You can also, if a whole bunch of numbers are thrown to you, you can look at what thing doesn't have a conversion or what thing isn't a conversion. You never start with a conversion, because what goes in this box down here? Nothing. Nothing goes down here. So conversions have a top box and a bottom box. So you never start with conversions. Lydia. Probably. If I was assigning you partial credit if you did the math wrong, you would definitely get it wrong. You definitely wouldn't get any partial credit. Most likely what happens is students who try to do a shortcut where they just write numbers get confused about what numbers go where. If your units all cancel out, then there's no confusion. Okay. So again, always show your 3 things. And again, if I'm assigning partial credit, if you do the math wrong, if your setup is correct, you'll still get most of the points. Just because you can't punch things into the calculator properly or you missed a decimal point, I'm not going to ding you because you missed a decimal point. But if your setup is wrong, then we have a problem. Okay, so 16 grams of H2O. That's great. What's my next step? Good. bring down my grams H2O. Do I bring down the number?
No.
No. Leave the number, bring down the unit and label. And grams H2O is handy. What do I need to get that to?
O2.
Good. Moles O2, or moles H2O. Moles H2O. So I need to get my grams of H2O to moles of H2O so I can use my mole-to-mole ratio. Can't use it with grams, can use it with moles. Where does this conversion come from?
Wait, I have a question.
Yes.
It says how many grams of O2, so wouldn't O2 be in the top right?
I can't convert from grams of one thing to moles of another thing.
Oh.
Eventually, we're going to get to grams O2 or moles O2.
Okay.
But I got to get my original chemical into moles first.
Okay.
Is it that way for all of them?
Yes.
Okay.
Yeah, you'll never go from grams of one to grams of another. You'll never go from grams of one to moles of another. You'll never go from moles of one to grams of another. The only time you'll ever have two different chemicals is when it's mole-mole. Does that idea make sense?
Yes.
Give me a thumbs up if that makes sense. Excellent. Okay, so where does a gram mole come from?
Yeah.
Periodic table. So go ahead and do that. Find out how many grams are in 1 mole of water. Not even close. 18? So, yeah, so you got 16 for the oxygen, and then 1 for each of the hydrogens. So in every 1 mole of water, there are 18 grams. Excellent. So let's just pause right there. Give me a thumbs up if this makes sense so far. What we got is good. Okay, cool. Now we got moles H2O, which is great. It's not quite what we want, but we're getting there. So we're going to bring down our moles H2O, and what we want is oxygen, but now that we have moles of water, we can finally convert chemicals. So moles H2O to moles O2. And this is where we need the what? This is where we need the balanced chemical equation. We know that if we have H2 and put it into O2 and we bowl them up, boom, we make H2O. That's great. So this is our balanced chemical equation. We need the balanced chemical equation to give us the mole ratio. This is not balanced. Exactly right. Can you balance this? How would you balance it?
It's in front of the H2O.
Put a 2 in front of there and there. 4 hydrogens, 4 hydrogens, 2 oxygens, 2 oxygens. Now it is a balanced chemical equation, and we're going to pull the big numbers, the coefficients, and those coefficients are going to be the numbers in the mole ratio boxes. So,
2 and 1.
holding on. Okay. Okay. So you said it's going to be 2 and 1. Where's the 2 going to go?
H2O.
Yeah. 2 is going to go in front of the H2O, and the 1 is going to go in front of O2. So you see the little 1 right here in front of the O2? That's what goes in the mole O2 box. You see the 2 in front of the H2O? That's what's going to go in front of the mole H2O box. Excellent. So now we are almost to our goal. Now we have moles O2, which is great. So we only need one more step. We're going to bring down our moles O2, and we're going to convert it to grams O2. And anytime we do mole and gram, where does that conversion come from? Periodic table. So go ahead and hammer that one out. It's 16 on the periodic table, but we're not talking about oxygen atoms, we're talking about molecules, so it's how much? 32. So
Wait, what?
okay, we're not talking about oxygen atoms. Like oxygen is 16 on the periodic table. But
Oxygen 16 grams, and then it's 2 oxygen.
exactly,
Yeah,
because
that's
it's
what I
oxygen
asked.
gas. It's diatomic. It's the awe in Brinkelhoff. Okay. So for every 1 mole of O2, we get 32 grams of O2. And now that we have the unit we want, we can do our math. Our math will just simply be 16 by, can we leave out the 1s?
Yes.
Okay, 16 by 32 divided by 18 by 2, whatever that happens to be. And the unit, when we do all this, will be whatever unit this is left over, that's going to be the unit of our answer. In this case, grams O2. I don't know how much that is, you tell me.
14.2.
14.2, is that right? Okay. 14.2 sounds pretty good. 14.2 grams of O2 is how much is required, how much O2 is required to make 16 grams of water with excess H2. Maybe we should remind ourselves what excess means.
Well,
Okay, whoa, hold on, Byron, that's too much. Okay.
16 times 32 is
I got
512.
512.
Okay.
18 times 2, I got 32.
36.
I got 36.
Hold on.
All right, cool. Again, the process is the most important thing because every now and then you miss a button, you hit a 2 or you should have hit a 3 or vice versa. Your math is all wonky. You won't lose a lot of points for wonky math. You'll mostly lose points for wonky setups. And most of these tests are going to be on paper because I need to be able to see your work.
Fantastic.
I know. Okay, so let's talk about excess. What does excess mean?
Leftover.
Leftover. It means there's plenty. So when we say excess H2, that means there is plenty of H2. We don't have to worry about it. The other thing that's not the excess is the limiting. In this case, if hydrogen is excess, oxygen is limiting. It limits how much we can make. Okay. Yes. Okay. Any questions so far? Let's do another one.
Fun.
Okay. Now, in this fun reaction, if you react 15 grams of HCl with excess zinc, plenty of zinc, how many grams of zinc chloride will you produce? And the chemical reaction, we've done this before, is zinc plus hydrochloric acid makes hydrogen gas, that goes boom, and
That goes
NCl2.
boom.
It goes boom. We dumped the zinc into hydrochloric acid and it blew up the balloon. We took it over there and lit it on fire and went boom! That's what we were talking about. And we balanced this yesterday. We balanced this yesterday by putting a 2 in front of the HCl.
Yeah.
So it's our balanced chemical equation. All right. How should we start this exercise?
15 grams of HCl.
Sounds good to me. So make our T, and in the top left, we're going to write our 15 grams of HCl. Why did I choose 15 grams of HCl? It's the only thing that's given to me. What goes down in this box here?
Nothing.
Nothing. Nothing goes there.
Big old
So I got my first step set up. What do I do now?
HCl grams now.
Bring down grams HCl, and we're going to convert our grams of HCl to
Moles HCl.
moles of HCl. Why do I need to convert it to moles HCl?
Because you have to go from moles to moles to mass.
Exactly. It's the only way I change chemicals. A mole to mole is the only way to change chemicals. So I need to get chemical A, in this case HCl, to moles so I can swap chemicals. All right, 1 mole of HCl is so many grams of HCl.
36.
So it's 36.
Where did you come up with that number?
CL
One
is
plus.
35, and then H is, our hydrogen is 1 and we add together.
Good. So off the periodic table, H is 1, Cl is about 35. So HCl is 36 grams per 1 mole.
Mhm.
Excellent. Next box.
Drop down the mole.
Am I going too fast or is this a good speed? Okay.
Fantastic.
So next box, what goes down here?
Mole HCl.
Mole HCl, and we're going to convert to mole zinc. Mole zinc chloride.
How come it's
CN2.
just zinc? Oh, okay.
It's zinc chloride.
That color is hard to read over.
I know. My projector is for crap. I'm sorry.
It's for crap.
So yeah, this says gram ZnCl2. Okay, cool. Where do I get these numbers?
The mole ratio.
Mole ratio. So HCl gives me a what?
2.
2. And CnCl gives me a
1.
1. All right. Now I've changed chemicals, which is great. I'm more than halfway done. So I've changed chemicals. Now all I have to do is turn my moles of ZnCl2 into what?
Grams.
Grams of ZnCl2. And I'll let you use the periodic table to find out what that number is. How much?
135.
135? Okay, again, if you got 136 or 137 because you rounded at a different time than your neighbor, don't worry about it. Your numbers are going to be close enough. So about 135 grams of zinc chloride. Yay, I have the unit I want. So when I have the unit I want, what do I get to do? Multiply 15 by 135 divided by 36 by 2, and the unit is going to be grams ZnCl2.
Yeah.
28. All right. 28 sounds good. So 28 grams of zinc chloride will be made if I have 15 grams of hydrochloric acid and plenty of zinc.
This is not as hard as I was looking.
Good. Yeah. This is the bulk of stoichiometry. Honestly, if you master this, everything else is just minutia. We are going to add more things to the idea as like little things that matter very little. So we are going to add more things next week, but this is the bulk of stoichiometry. Taking chemical A, converting it into moles, using the mole ratio, back to moles of B to grams of B. Okay, now this one I'd like to do on your own. This is H2. So how many grams of H2? That's what that's saying.
In what?
So set it up exactly the same way. So grams HCl. So start with grams HCl again. But now I would like you to solve for grams of H2 gas. Try to work that one on your own.
Oh, so instead of doing the zinc chloride, we do H2O.
Exactly. Or H2, just H2, hydrogen gas. So instead of, at this point, this is going to be the same, but at this point here, instead of getting moles ZnCl, I'd like you to convert to moles hydrogen
Okay.
and then grams hydrogen.